Thank you all for attending my talk, The Mathematics of Democracy. I'm Alex Halperin, and I'm going to be talking about some ways in which mathematics pervades democracy and policy making and can help us understand the world around us. So first off, let's just remind ourselves that mathematics exists in every facet of everything. It's all around us in the world, and that includes democracy. So first off, let's just remind ourselves what we mean by democracy, which is a system of government in which the people or citizens take part in how the politics work and operate. And the way mathematics is going to help us is that it'll help us understand things in the world. Now, I personally, as a mathematician, think that mathematics is beautiful and worthy of research in and of itself. But when we're applying it to things in the real world, like the sciences or public health, or just understanding democracy, then we want to use it as a tool. And when we do use it as a tool, when we think about ways to apply mathematics, we better understand our government, we understand public policy, our ability to affect change, and maybe some things that we didn't even have a clue about before. So let's dive in. Now, first what we're going to do is something that we just did a second ago. I specifically defined democracy. I guess you can decide how specific my definition was, but one thing in mathematics, one of the truly great things about mathematics is how logical it is. We define our terms clearly and specifically so that we and our audience know exactly what we're talking about. It's always important to define our terms well so that, again, number one, people know what we're saying, we know what we're saying, but number two, people can't dispute the veracity of our arguments, right? If I'm using nebulous terminology, then people can say, hey, wait a minute, you're wrong, but maybe I wasn't wrong, they just misinterpreted me, or maybe I misinterpreted myself. But if I'm very clear about what I mean, and I say things that are facts, then no one can dispute them. In particular, if we use numbers, then in theory, that means we're being honest, right? Well, maybe we'll see some examples of how numbers can be used to deceive. But in general, mathematics and precisely defined terminology gives us a way of objectively talking about things and clearly talking about things. So for example, you have to be careful, even when asking a simple question that you've probably heard before, like, is infinity a number? That's a question in math you hear a lot, right? You know, and if you took like pre-calculus or something, then your teacher probably told you, well, no, infinity is not a number. But you might want to first ask the question, what's a number? What are we even talking about? Right? If you ask 100 mathematicians, what's the definition of a number, you'll probably get 100 different answers. And that's because there are a whole host of different ways to consider numbers, right? We count things, we can talk about negatives, we can talk about the real numbers, which is probably what your pre-calculus teacher was talking about when they said infinity is not a number. No, because it's not a real number. But if you take more advanced math classes like real analysis, you consider the extended real numbers. That's all the real numbers, including plus or minus infinity. There are also the complex numbers, which is all the real numbers, but you can also include the square root of -1. And then there are these things called the surreal numbers, which have infinitesimals and all sorts of infinities, and I can't even begin to describe it. The point is, depending on what you mean by even just a simple word like number, you could have vastly different answers to a pretty straightforward question. Now, let's go back to politics and democracy. Specific terminology is so important because, as Dr. Rittinger once said, the people don't know what they want. Now, he was talking about polling back then. Depending on how you ask certain questions, you can get different responses from people because they might be thinking about different things. They might have certain feelings that come up. And so we really want to be as precise as possible to know what we're talking about and to know what other people are talking about. So what I want you to do is take a minute, think about some nebulous terms that appear in the political discourse. Normally, if this weren't recorded, then I would stop and just let you think for a minute. Here, I'm just going to go on. But if during the talk, you think about, oh, that's a good term, I should write that down, then write it down, and I want to hear about this in the Q&A, and I'm going to write your terms in this blank slide right here. Okay. Just to let you know, some of my nebulous terms are here. I think some of them are kind of obvious why they're nebulous, right? They mean different things to different people, right? Gender, if you've been following the Supreme Court, right, gay and transgender rights just got a very big boost from, I think, a somewhat unexpected decision in which the court interpreted gender-based discrimination more broadly than other people might have expected. Cut and tax both relate to healthcare. We'll be getting into that a bit later on with the word cuts. Tax, I just want to point out, that was crucial to the ACA being upheld by the Supreme Court in 2012. The mandate was considered a tax, so Congress had the right to levy it against the people, but it didn't count as a tax for the purposes of the Anti-Injunction Act. I think that confused a couple of people, including me. But the point is, the Supreme Court had its very specific definition of tax. And that definition determined healthcare for hundreds of millions of people, and whether or not tens of millions of people actually got healthcare. So definitions are important. The middle terms are I think they're pretty clear why they're nebulous. Hats off to you if you know why I included is. If you're not sure about that, check out definition of is. Just Google that. And then the last three are things that we I think are pretty relevant today. Privilege. The term white privilege might mean something different to someone who's heard that term before compared to someone who hasn't heard it before. Defund. When we talk about defunding the police, what do we really mean by that? I think that might be part of the purpose of the term defund, is to talk about what we mean by defunding the police. And then downplay, a little bit of a jab at the president for his admission of how he handled the coronavirus. He claims he downplayed it, and then he said, no, he didn't downplay it. I think he's not clear about what he means by the word downplay. And now I'd like to turn our attention to policy promotion and presentation. I said before that numbers are honest, right? And maybe that's not totally true, right? Maybe when we're illustrating our policies, we want to use the best numbers that we can to drive our point home. And maybe if we're attacking a policy, then we want to use the numbers that best, attack the policy. But maybe we don't always paint the most complete picture. And so maybe I think we have this tendency where when we hear a statistic being cited or a fact being stated, we think about that one fact and we don't think about what it means in the big picture. So I'm going to show you a couple of pairs of statements that appear to be conflicting, and I want you to think about how they could both possibly be true. From 2010 to 2013, roughly 500,000 people immigrated from Mexico to the U.S. I don't know if any specific person said that. I've read it in articles. But that was the main message of Donald Trump's speech when he declared that he was running for president in 2015. Bill Clinton, a couple weeks later on The Daily Show, responded by saying, from 2010 to 2013, the U.S. saw negative net in-migration from Mexico. So how could both of those be true? How could we have roughly 500,000 people coming in and somehow a net loss? Well, if you think about it for a second, I guess a lot of people over that same time period, more than 500,000, were going from the U.S. to Mexico. That's something that had to do with perhaps the U.S. economy, the Mexican economy, where people were. Maybe people got educated here. But both of these statements were true. Okay? And it's not something that you might have known. It's certainly not the picture, I think, that gets painted regarding immigration. So I'm not sure if this changes anyone's minds on immigration, but it does at least paint a more complete picture. Here's one from 2008. Senator Obama's secret you don't know is that his tax increases will increase taxes on 50% of small business revenue. That was said by John McCain. Obama responded, 98% of small businesses make less than $250,000. So the vast majority of small businesses would get a tax cut under my plan. How could both of those statements be true? Well, if you think about it, I guess that means that 2% of the small businesses are bringing in 50% of the revenue. Right? I guess that's sort of the only way that could be square. Which, to me, makes me wonder, what counts as a small business? I might add small business to the list of nebulous terms there, because how small can a business be if it's bringing in most of the revenue? One more example, and this really played games with my head. I had to read this one several times. Under GOP healthcare reforms, there would be a reduction of $772 billion in federal outlays for Medicaid over 10 years. That's what the CBO said about the newest Republican healthcare plan in 2017 that they were trying to use to replace the ACA or Obamacare. Ari Fleischer, a Republican, responded by saying there are no Medicaid cuts in GOP healthcare reforms. How could those two things possibly be true? Well, it turns out that Medicaid spending is set to increase and increase and increase. Every year, we are set to pay more and more money on Medicaid. A lot more money. More than the inflation rate. It's to keep up with rising healthcare costs and perhaps the growing population that will need Medicaid. So what the Republican healthcare plan was going to do was it was going to reduce that extra spending so that only a little bit more was being spent each year. So if by a cut you mean spending less on Medicaid than in the year before, then no, there were no cuts. But if by a cut you mean spending less than we would have spent that year, well, then there were cuts. So it's weird that you can say Medicaid is going to be cut, but then also say Medicaid spending is going to increase. Doesn't seem like you could square that circle, but again, depending on what you mean by a cut, both statements could be true. So just want to point out these are hopefully some examples to show you the importance of knowing your terms, defining your terms, conveying your information to the people, and also just showing you that numbers aren't the be-all, end-all of complete honesty. Nothing substitutes for a more complete understanding. It's always good to get more numbers. Don't just hear one statistic and think you know the whole picture. Really understand the situation as much as you can by getting lots of numbers about a situation. Okay. Now let's move our gaze to something a little bit more technical, gerrymandering. Hopefully we're all familiar with the term, but if not, just a quick primer. The U.S. determines its congressional seats by state populations, right? Depending on its population, a state is carved into various districts, areas with roughly the same number of people. And each district elects a representative that goes to Congress and advocates the federal government for their district. Right, they try to pass federal policies or vote for federal policies that benefit their district. Now, the key thing, right, the more people you have in your state, the more districts you get. The purpose of districting, right, is to give somewhat proportional representation to the states. I say somewhat because the most populous states don't get the full proportional advantage, right? California, for example, should be getting 68 times as many reps as Wyoming, but it gets only 53 times as many. But the other nice thing about districting is that it represents different groups of people within each state, right? New York City is vastly different from basically every other part of New York, right? Certainly from upstate New York. So you might have a wildly different representative from upstate New York as you do from New York City, right? Because New York City people and upstate New York people have very different needs. But the question might become, well, it's easy to say things like, well, New York City is different from Homer, New York. It's not so easy to say exactly where do you draw the lines, literally. Where do you draw these district lines? And that brings us to the definition of gerrymandering. Gerrymandering is the practice of manipulating the boundaries of an electoral populace, usually in order to favor one side. So, for example, if you take a look at the North Carolina Republican-drawn congressional gerrymander in 2012 to 2014, we see 10 red districts, right? These are 10 districts that voted for Republican representatives, and only 3 districts that voted blue, that voted for Democrats. Now, North Carolina is a pretty reliably red state, but I don't think Republicans outnumber Democrats 10 to 3. I don't think it's anywhere close to that. And I think if you look at these districts, some of them look a little screwy. I'm not sure that if you were to randomly divide the state into, 13 districts, that you would come up with these shapes. I don't think you'd do that. Right, now, granted, there is some geography we don't know, right? Things like cities are very important, right? You have to be a little careful when drawing boundaries for a city. But some of it just seems really weird. Like District 12, what's going on there? You know, even District 4 and District 1, why are they sprawling out all over the place like that? So this is an example of a gerrymandered district. This was done to maximize Republican representation and minimize Democratic representation in Congress. And it worked. The good state of Maryland. This has possibly the single worst district in the country. If you take a look at District 3, I don't even know what to call that thing. It looks like a piece of seaweed or something. I don't know. There is no conceivable way you could just randomly come up with a district like District 3. District 2 isn't a whole lot better, by the way, but anything is better than District 3. So, which districts are unfairly gerrymandered? I'd say certainly, 2 and 3. 4 doesn't look so great either. What about ours, right? We're in District 1. Seems better. Kind of wraps over the others a little bit there. 6 kind of does something similar. 5 and 4 kind of go into each other a little bit. This is very unfairly democratically gerrymandered, right? 7 Democratic seats and only 1 Republican representative, right? Andy Harris in our district. But just because this happened, it doesn't mean that, Democrats intentionally did this, right? It's not like we have an admission or anything. Just kidding. We totally have an admission. In a deposition, in a lawsuit, the former Maryland Governor Martin O'Malley said, he wanted to change District 6, which was reliably Republican for 20 years, to being Democrat. A 6-2 advantage was just not good enough for him. He wanted a 7-1 advantage. And he said, and he wanted to create a district where the people would be more likely to elect a Democrat than a Republican. Shame on you, O'Malley, right? He actually just admitted this. I'm not sure we have similar admissions, but I'm not sure, like from other states, but I'm not sure we need them. The intent is always pretty clear. But what makes a district problematic? What makes it bad? How do we measure these sorts of things? Well, in general terms, these districts tend to be long and thin. They've got jagged spikes. They're tentacle-like, right? They wrap around other districts. They are not compact. We'll get into that a little bit more in a second, right? But basically, they don't look squarish or circular-ish. They're not convex. If you were to draw a line between 2 points, the line would probably leave the district. That's not a good thing. There is something called opposite sides of the street districting. I think that was Dr. Surak used that term at one point. I think I saw there was a race in Pennsylvania where they ran along the boundaries of a district, and it was this crazy running route because the boundaries made no sense. Right? You don't want to do that sort of thing when you're districting, right? Or maybe you do if you want to provide an unfair advantage to your party. But the question is, how do you objectively measure this kind of stuff, right? We can kind of look and say, well, that's a bad district, that's a good district. But I'd like to measure how bad or how good. Well, we can use some geometry. We can talk about the dispersion measure, which compares the area of the district to the area of the smallest circle containing the district, right? If you take a look at that District 12 in North Carolina, that blue sliver there, this big black circle is the smallest circle that will contain it. And I think we can just tell by looking at it that the dispersion score is going to be pretty low, like, 1 out of 10 or 1 out of 15 or something like that. All right, in Maryland, something similar, right? District 3, I probably could have made that circle a little bit smaller. That's not going to have a very high dispersion score either, right? That's going to be, maybe 1 out of 5 or something like that. District 3 doesn't actually do quite as badly as I thought it would because it's a little bit more compact, but it still does very badly. It's still no more than a fifth. And the closer, I think you can see this, the dispersion score is going to be between 0 and 1. The closer you are to 0, the more problematic your district is, right? Because the closer to 0 it is, the longer and probably more jagged it is. Not what a district should probably look like. Okay. Another one is the Polsby-Popper or perimeter measure. It's a little bit more complicated. The area of the district, right, that red area in square units, divided by the square of the perimeter of the district. Remember, the perimeter is the length of the boundary. So if you trace around that red region right there, you get a line that I think the length is roughly the length of one of the sides of this big black square, just one of the sides. Well, you take that length and you square it, and that gives you the area of this big black square. So it's another way of comparing the area of a district to the area of a square, in this case a square containing it. Right? By squaring the perimeter, we're comparing a two-dimensional measure, area, to another two-dimensional measure, square of the perimeter. Right? And so we get, just to be a little technical here, we get something called a dimensionless measure, right? P is a dimensionless measure, which means it has no units, right? Because area of the district, square units, divided by the perimeter of the district, square units. And that's just nice because you don't need to worry about scaling, sort of thing. Right? So again, this district, that red district, pretty badly gerrymandered because Polsby-Popper is going to be pretty close to 0. There are other things you can do if you want to be more precise. You use a convex hull, which looks at the smallest convex polygon, with a limited number of sides that contains your district. You can compare the circumference of the circle, that's equal to the perimeter of your district. You can talk about the X or Y symmetry. You can use the dispersion method with a rectangle instead of a circle. This website down below here has a great list of these things. Very short descriptions, very nice pictures. I recommend taking a look. Just a super quick glance, just a couple of minutes. Again, just to give you some good, quick measures for how to measure gerrymandering. One nice thing about these measures, they're very short formulas. They're objective, right? In fact, they're dimensionless, right? Again, no one can dispute these results. You can say, look, the dispersion score is low. It's not the be-all, end-all, but you can say, look, low dispersion score, evidence of gerrymandering, right? And I think that generally speaking, they work with our visual intuition, right? If a district looks very badly gerrymandered, then it's probably going to have a low dispersion score or low perimeter score, right? Maybe not always, right? If a stat never surprises you, then it's useless. But this is a good way to measure our intuition or measure the problems of gerrymandering. A couple of problems, though. These aren't perfect, right? Certain weirdly shaped states like Maryland just have a bizarre shape, and so some of their regions, some of their districts just aren't going to look very circular because that's how the population is spread out, and that's how, that's how the state looks. This is especially tricky when it comes to cities, right? Because a lot of people pack themselves into cities, and districts have to have the same number of people. So it can be very difficult drawing border lines within cities, and those border lines might get punished by these, measures, perhaps even unfairly. Also, it's conceivable that, a certain weird shape might not be so bad under the dispersion or perimeter measure. Right, that red district looks kind of weird, but I don't think its dispersion or perimeter score is all that bad. Let's take a look at Wisconsin. Now, by the way, we're switching gears here a little bit. We're still talking about districts, but we're talking about state assembly districts, not congressional anymore. These are districts to determine the people in the state legislature, right? The people in the Senate and the legislature who write the laws. Okay? Looks like Republicans did pretty well in 2016, about a 2-to-1 advantage over Democrats. I believe Republicans won 66 or 65 seats or something like that, and Democrats won 34 out of 99. But I don't know. If I take a look at the districts themselves, they don't look anywhere close to as egregious as the ones in Maryland and North Carolina. You know, they look relatively convex, relatively compact. They're not a whole lot of tentacle-like things going on here. Maybe some shifty business right there, but nothing like Maryland's 3rd district. Is this really bad gerrymandering? Well, if we take a look at 2008, yeah, it kind of is. Democrats did much, much better in 2008. And I think those districts look even a bit better than they do in 2016. And this was pointed out to me by someone. I gave a similar talk a few years ago, and someone in the audience pointed me to this New York Times article that talks about the new front in the gerrymandering wars and how Republicans were able to gerrymander the state of Wisconsin, because, again, those districts looked pretty legitimate. Turns out they were able to do this thanks to a program written by Keith Gaddy, a political science professor at the University of Oklahoma. He gave them this tool so that they could create these districts and figure out with high likelihood whether they were going to be red or blue. So, using this computer program, you could create good-looking districts that were actually very advantageous for one side or another. And again, this is the sort of thing you could do only with a computer program, only with lots and lots of data. And I think a bit of an understanding of geometry, right? And these scores. You want to make things look good. So the way that you can call this sort of thing out is to say, hey, look, if you were to randomly create 99 equally populous districts in the state of Wisconsin, even taking cities into account, then it's very, very unlikely that Republicans would have a 2-to-1 advantage over Democrats like this. You know, in fact, you could argue that it's 1 in a million or 1 in several thousand. But how are you really going to prove that? Well, you'd have to randomly create districts, you know, like millions of districts, and then for each of those districts, run them through thousands of voting simulations under different political circumstances. You know, maybe some years Democrats are more favored. Some years Republicans are more favored. It's possible to do this, but it's very difficult. And people have done this in other states. We're going to see one in a second, Pennsylvania. But it's very difficult. That's something only a few experts can do, and with a lot of hard work. Instead, it's much easier to use a couple of simple measures. So the easiest thing to do is to just compare the total statewide Democratic vote and the total statewide Republican vote. Look at their proportions, right, their percentages, and compare the percentage of seats that they won, right? So, for example, in 2016, Republicans won 53% of the vote. So you figure they should have run roughly 53% of the, I say the congressional seats, but again, I mean the state congressional seats. But they should have won roughly 53% of the seats. Instead, they won 65%. Right? They won 64 seats. So they won 12% more seats than we would have expected them to. Doesn't prove anything, but that suggests a bit of Republican gerrymandering going on. That's quite an overachievement. Or, you know, maybe you could say that's quite fortunate of Republicans. But the even better measure, although it requires a lot more data, is something called the efficiency gap. The efficiency gap measures the proportions of wasted votes. So what you do is you look at all the districts. So we're going to focus in on the Democratic votes and losing districts, right? Look at all the districts that Republicans won, right? All 64 of them. Count the number of Democratic votes. Divide that by the total number of votes, right? Just to get it into proportion, right? That's a proportion of the wasted votes in those districts, right? Right. Losing votes are wasted votes. Do an analogous thing with the Republican votes, right? Again, you look at all the, what was that, 35 districts that the Democrats won, count the number of Republican votes, divide it by the total number of votes, and compare them. Subtract those two proportions. Well, it turns out that in 2016, Wisconsin had an efficiency gap of negative 10%. So Democratic votes were 10% more wasteful than Republican votes. Okay, that is to say, Democratic votes were much more likely to be wasted. Okay, that suggests Republican gerrymandering, right? That suggests that, Republican designed this to maximize the wasted number of Democratic votes. The more I look at this formula, the more I think it should actually be positive 10%. Sorry about that. Or you could flip Democratic and Republican votes. So sorry about that. That negative sign should actually be a positive with the formula that I drew. Okay, but again, 10% of the Democratic votes were wasted. One more map, and I don't think this gerrymandering is quite as interesting as Wisconsin's, but what happened with it was. 2011, Pennsylvania had this map. I think we can see that that's pretty clearly gerrymandered. Republicans had a 2-to-1 advantage, even though we know that Democrats and Republicans are roughly evenly populated in Pennsylvania. It's closer to a 50-50 than to a 2-to-1. The Pennsylvania State Supreme Court actually said this map is unconstitutional, draw another one. So the Republican legislators said, sure. And this is what they came up with. I think it looks better. I actually think it looks a lot better. But from an advantageous standpoint, it's the same, right? They're still winning 12-6. Or they would, in theory, win 12-6. They would likely win 12-6. Well, surprise, surprise, the Democratic governor, Tom Wolf, objected and said, no, I'm not going to accept this map. He had the power to do so. And to back up his point, he hired Dr. Moon Dutchin from Tufts University to take a look at this map and see how likely this advantage was, sort of like what we were suggesting in Wisconsin. And what she said was, bias in favor of Republicans is extremely unlikely to have come about by chance, roughly a 0.1% chance. That's 1 in 1,000. So this map was carefully drawn to look good, but give Republicans a maximum advantage. Instead, Governor Wolf turned to Nathaniel Persily, a professor at Stanford Law School, who drew this map on the left, which is much more fair to Democrats, right? Republicans are still winning, but by more closely to the percentage of Republicans to Democrats in the state, right? And so, of course, Republicans were upset about this, and, 538 even had an article that said, the new Pennsylvania district benefits Democrats, but it's not gerrymandered, right? This is just what you should expect to see in a state like Pennsylvania. Again, the districts aren't perfect based on our geometric scores, but using the efficiency gap, they're actually very good. And so I guess we're going to see this new map in action. We saw it in 2018, but we'll see it again in 2020. We'll see how that works out. So just to show you, it's not always easy to figure out. It's easy to identify gerrymandering, but it's not always easy to figure out the proper solution. It may not even be clear what the proper solution is, right? We have to define that. So what I want you to take away from this is that gerrymandering is a very, very important issue. It can greatly determine the representation that different groups of people get. Certainly can determine the representation for Democrats and Republicans. Sometimes we have to be a little bit careful about how we measure things because even good-looking districts can still have huge efficiency gaps. And once we figured out that gerrymandering exists, it can be really difficult to come up with an optimal, fair solution. We can come up with a solution, but we want to make sure that it's actually better. And really, we want to keep striving to achieve the fairest districting system possible. first by figuring out what that means and then executing. Last but not least, I want to talk a bit about polling because I think there is an election this November or something. Please register to vote and please vote. Even if you don't support anyone, then just submit a blank ballot. It's better than not voting. It's better to participate in your democracy than not to. Please vote. Polling is what determines, or is what I should say, illustrates public opinion, right? Polling measures public opinion. We rely on polling to figure out what people think about issues. It's really, really important. And that means that it's really, really important for the pollsters to get the results right. Well, they often do. They often do. Even when it's difficult to poll, right? 2008, right, the presidential election, the polls were pretty accurate. Nate Silver had this model that just nailed the election. 2012, Silver's model again used the polls, did even better, predicted every state, predicted almost every Senate race. 2018, right, there was all this talk of a big blue wave. Well, it happened. There were a couple of polling misses, but I would say that generally speaking, the polls captured the national feeling and pretty well predicted the congressional outcomes, which again can be very difficult for congressional races. There aren't a ton of polls done. People often aren't aware of them until right before Election Day. That said, we also had some bad polling years. 2010, again, another off year, not a presidential year. The polls did detect that Republicans would have an advantage in the election, but Republicans really took it by storm. They did really, really well, much more than the polls estimated they would. 2016, of course, I'm not sure how many legitimate polls, if any, had Donald Trump winning the election. Nate Silver's presidential prediction was way off. And maybe we'll talk about some of the reasons why those errors occurred and what we can learn from them. So first off, let's understand what pollsters are trying to do. They want to capture the national mood, the national feeling about certain things. But they can't actually poll everybody. There's just no way to do that, unfortunately. So what they have to do instead is they create these small-ish sample polls where they randomly select people and ask them these questions, get their results. They want the samples to be large enough to be meaningful, but, also they want to conserve resources because they want to do this multiple times. They want to make sure to really randomly choose people so they're not targeting one group more than they should be. And they also, and this is what Dr. Rittinger was talking about, I had mentioned before, pollsters need to be very careful about how they ask questions because depending on how they prime things, they can get people thinking in one direction or another, and they really just want people's honest opinions. So the way that they do this is they take these samples, they find their proportions, and you'll often see a 3% margin of error. And if you're wondering what that means, that's the likely amount that the poll is off by. Right? So you could say, well, maybe the poll is 3 percentage points too high or 3 percentage points too low. Now I'm showing you this complicated margin of error formula right here because we're going to use it in a second. What I want to illustrate is two things. Number one, the higher the margin of error, the more uncertain our poll is, right? Most polls have a margin of error of 3%, which is a pretty good margin of error. But the other thing I want to say, and we'll see how they get that, is that the margin of error depends only on the proportions that we're talking about and the number of people who are polled. It doesn't depend on the population of the country. So whether we have 100 million people here or 300 million people here, whether you're Osmosis Jones and you're in the human body and you're polling all 6 trillion human cells, it doesn't matter. Your margin of error is determined only by your sample size and the proportion of people who think a certain way. Like in this case, the proportion of, Trump supporters. Okay? Let's take a look and see how many people we need to poll in order to get a margin of error of 3%. Let's try 100. I don't know. Right? If we poll 100 people, then we plug 100 in for n, and we say, okay, who are you going to vote for in this presidential election? Suppose 42% of them say they're going to vote for Donald Trump. Okay, well, plugging that in, right, for p hat right there, gives us a 9.67% margin of error, which is not so good, right? Because that means that Trump's true support level is likely between 32 and 53%, right? Not 100%, but it's likely between that. Well, that doesn't really tell us a whole lot, right? 32%, he's certainly losing. He's getting crushed. 52%, he's certainly winning. Right? So we need to poll more than 100 people to get a meaningful margin of error. Again, 3% is what we're looking for. So what we do is you go back to this guy right here. See how n is in the denominator right here? You square both sides, multiply both sides by n, and divide by the margin of error squared. Right? And anyway, you get this. For technical reasons, you plug 0.5 into p hat. You want to maximize it, basically. And you plug 0.03 in for margin of error, and you get, don't worry about the formula if you can't follow, but the point is that by solving for n, you get 1,068. That is roughly the number of people you need to sample to get a 3% margin of error. Again, it doesn't matter the population of your country. This is the number of people you need. Right? And as a result, when you look at most polls, like an ABC News poll that comes out, they sample roughly 1,100 people. Some a little bit more, some a little bit less, so that way they can have a margin of error of 3%. 538 has a great database on this, unlike the recent polls, and they show you the sample size. Most of them are in that 1,100 range for that reason. Okay, well, right now, I took this data from 538. I think it had a Trump support level at 43% or something, but I looked at one of the polls and it said 42. So if we randomly poll 1,068 people and 42% of them say that they're going to vote for Trump, then we know that his true support level is likely between 39 and 45%, which is helpful because if in that same poll 50% of the voters say, oh yeah, I'm gonna vote for Biden, well then Biden's true support level is likely between 47 and 53%. Well, I don't know, that looks like Biden's gonna win no matter what. But, of course, it's not gonna be that simple, right? There are two reasons for this. Number one, there are those 8% of voters who are undecided, right? Maybe they'll vote for a third party. Not sure there's really any prominent third-party candidate this year. But maybe they're just going to decide late. Now, a lot of times this doesn't really make a difference, right? In 2008, 2012, late deciding voters weren't really a huge factor at all. 2016, they were. James Comey made his announcement, right? And the polls instantly shifted 3 points in favor or closer to Donald Trump. And late deciding voters were one of the big reasons that Hillary Clinton lost, right? They went 2-1 towards Donald Trump. So they might be a factor, right? The other problem is that it's very possible that the polls are biased, right? The margin of error doesn't mean anything if the polls don't accurately represent the population, right? In 2016, white voters came out to the polls and voted a lot more than expected. And so what happened was the pollsters underestimated the white vote, and so they got their proportions wrong. Now, I just want to be crystal clear. This doesn't mean that if the demographics in our country are as displayed right there, that you need to precisely poll 62% of white people and 13% of black people. You don't need to do that. Your sample size doesn't need to be that precise. All you need to do is correct for the true proportions, right? We can weight our populations, our subpopulations. So what I mean by that is if we conduct an 1,100 person poll, that's 50% white, 20% black, etc., and they don't match up with the national proportions, there's an easy way to do that. You just multiply it by the true proportion divided by your sample's proportion. Right? So if you want to know the true proportion of white people who support Donald Trump, well, your sample had 50% of white people, you just multiply Trump's support by 62/50ths. To know his true black support, you do, okay, his black support times 13/20ths, right? Because the true proportion is 13. Your sample's proportion was 20. And you just keep doing this. So when I'm talking about biased polls, I don't just mean polls that happen to survey different proportions from the national standard. What I do mean is that if more white people vote, like if more than 62% of the voting population is white and non-Hispanic, and maybe fewer than 13% of the voting population is black non-Hispanic, then we misweighted our populations and our polls were off. They were biased. They weren't intentionally biased, but they were biased. They underrepresented white people and overrepresented black people. The reason is because likely voters can be different proportions from people in our country. Right? And that's exactly what happened in 2016. White turnout was high, black turnout was low. And so Trump's support was being underestimated by biased polls. This year, we could have a huge problem with that, right? Because certain groups of people might be more unlikely to vote because of COVID and mail-in voting. 538 just released an article a couple of weeks ago that black mail-in votes were disproportionately rejected compared to white votes. Not that there was any intentional animus necessarily, or perhaps there was, but more it's just that black voters happened to run into problems that the white voters seemed to be able to avoid, because they're new to mail-in voting, or there were certain resources weren't available to them. Regardless, if this affects the racial turnout when it comes to voting, then there could be a very big swing that the polls might miss. So it's going to be very, very important for voters to make sure that their votes are counted, and it's even more important for the pollsters to know this and try to figure out what proportion of the vote is going to be counted. So a lot of time polling can be more of an art than a science. But that said, the pollsters are really just have a bunch of different things to consider. So anyway, the takeaways from this are that if you want to poll the population, 1,100 is your sample size, right? Make sure your sample is random. If you have a systematic error, then your polls might be worthless, or certainly they might be inaccurate, okay? And if you don't know where your polls are going to go wrong, then there's no magic formula to fix them up. So just try to consider as many different things as you can when you're polling. So I just want to bring this around to our final thoughts, right? Using math, I'm hoping that I drew a couple of connections between math and democracy, or math and public policy. That we solved some problems. We identified some problems using math. We solved some problems using math. And we also maybe discovered that certain answers were a little bit out of our reach for now. But that inspires more mathematical research. So perhaps in a few years we can look back and say, hey, we've made progress thanks to math. That's all I've got for today. Thank you.